Hello and welcome all to today's discussion about Apache Cassandra performance tuning. In this, we are going to touch upon briefly about what is Apache Cassandra and high-level architecture of Apache Cassandra. Then we'll go deep down into performance tips for Apache Cassandra. First 2 points we are not going to discuss too much in details. We assume that you know Apache Cassandra, how to use it, different APIs, commands, and all those things. So we'll be going deep into the performance tips for Apache Cassandra in this discussion. So starting with what is Apache Cassandra? Apache Cassandra is a NoSQL database. Okay, like most of the NoSQL databases, it is schema free. It doesn't require you to define schema upfront, so it's very flexible from that point of view. And Cassandra is built for fast writes. So the speed of write in Cassandra is tremendous, and it is built specifically for those use cases where you have you need high throughput from write perspective. Cassandra is designed to handle big weight data workloads across multiple nodes with no single point of failure. So in Cassandra, there is no single point of failure kind of thing, because all the nodes in a given cluster, Cassandra cluster, they are equal. There is no master slave or nothing. There is no node which enjoys some special status. So there is no single point of failure in Cassandra. Cassandra does the problem of failures by implying peer-to-peer architecture. So it's based on peer-to-peer architecture where all nodes are equal. So distributed system, it's across homogeneous nodes where data is distributed among all nodes in the cluster. So you have different nodes. All nodes will be will be storing some pieces, some chunks of that data, and each piece of data will be replicated as per the settings. So there is no there is no scenario where your data will not be available. Now we'll discuss high-level architecture of Apache Cassandra. So in this slide, what I have done is basically I have categorized different Apache Cassandra services into different categories. It's not a standard categorization or anything. I've just done it for simplicity purpose. We'll not discuss individual service in detail because that's not the objective of this presentation. But just to explain that one set of services, you can assume that they are kind of core services in Cassandra, which are system key space, peer-to-peer gossip protocol, and then there is Cassandra daemon, storage service of Cassandra, and messaging service. So these are our core functionality of Cassandra, how Cassandra works. Another set of another set of services, you can call it data related services, which are mem tables, SS tables, commit logs, and compaction. So first three basically are the functional blocks or the functional components which based on which your read and write operations happen in Cassandra, and compaction is related to the compaction of that data. Another set of service, you can call it housekeeping service or helper services, which keep Cassandra up and running with all those additional features. For example, anti-entropy and read repair, to see because you have a replicated scenario, one piece of data can have multiple copies. So if they are out of sync and there's those kind of scenarios, so these services will be used. Same way, there is a hinted head of Bloom filters, tombstones, which is related to deleted data. As I said in the beginning of this slide, we'll not discuss in detail of any of these services. So for that, you can refer Cassandra documentation and anything. But these are high level, most important or most critical services of Cassandra. So if you are working on Cassandra, you should know what are the services which is running inside Cassandra, how Cassandra is handling different scenarios. So that you can work individually, on individual pieces whenever there is a requirement to tune any of these components. Now, next couple of slides, we are going to briefly touch upon write and read process in Cassandra, so that we know exactly what is happening behind the scenes when write and read is happening. because most of the tuning will be related to these two processes. These two forms the crux of any database, read and write. So we'll just briefly go a little bit in detail about these processes. When write happens, what exactly is happening under the hood? A sequentially written commit log on each node captures write activity to ensure data durability. So first commit logs will be written onto the disk. Data is then indexed and written to the in-memory structure called memtables. So once the commit log is written, then it will be placed in memory structure called memtable, which resembles a write back cache. Once the memory structure is full, the data is written to the disk in SS table data file. This is your actual data file where data is being stored permanently. So once your data memory structure is full, it will be flushed into the SS table file, and all writes are automatically partitioned and replicated throughout the cluster. So depending upon the generated hashed partition key and settings of replication, it will be automatically placed to the appropriate node, and also replication will happen. Client doesn't need to worry about which node the data actually belongs to and where it will be going. It will be automatically handled by Cassandra for you. And there is a process called compaction. So what happens is that whenever the old data is being deleted and everything, so during delete, Cassandra only marks those data is deleted. It's called tombstones, but it doesn't actually delete it. So compaction is a process where when you have multiple many tombstones and all those things, so compaction will happen and it will actually delete those tombstones, and it will consolidate different SS tables and create a new consolidated SS table file. So this is a high level write process. So first the commit log will be written, then data will be stored in memory structure called memtable, and then finally it will be flushed to SS table, which is a disk based data file, and on regular intervals there will be compaction happening, which will be cleaning up your SS table files and merging them and creating new ones. Okay, continuing with this read and write process of Cassandra. So client read or write request can be sent to any node, irrespective of whether that node has that particular piece of requested data or not. And when client connects to a node with a request, that node will act as a coordinator node for particular client operation, and this coordinator acts as a proxy between client application and nodes that own the data being requested. So when you make when you as a client make a request to Cassandra that I need this particular piece of data, it may happen that that piece of data is lying somewhere else in the cluster. So now whatever node you are connected to, that will act as a coordinator node, and it will determine which node is is having that piece of data which you have requested. So it will actually act as a proxy between your application and the data being requested, and then coordinator determines which nodes in the ring should get the request based on how the cluster is configured. So you can configure partition strategy and replica placement strategy. Based on that, it will determine which node is actually having that data, and it will appropriately transfer that request. It will basically coordinate with that node to get you that data. Now we come to the core of this presentation, performance tuning for Apache Cassandra. So now we are going to discuss some of the key performance tips to get better performance out of your Apache Cassandra. Okay. So first, it's not specific to Cassandra only, but for most of the systems, and especially NoSQL world, that we have to model our database appropriately and very carefully. Generally in big data NoSQL world, generally the way we model our database, it's quite different from how we model in RDBMS world. So we need to understand our application, the different use cases and access patterns, how data is being accessed in our application. That is very important, because that will determine the way I will model my database. So I need to understand the application flow and access patterns very carefully. And a NoSQL database is generally modeled around these access patterns, which is very different from RDBMS world. RDBMS world, we generally how we model it, we define entities or something which represent the actual word, and then we define relationship between them, and then we try to fulfill the reporting and that kind of requirements using joins and all those things. In RDBMS world, that's how we used to do, but in NoSQL, the way we model our database, it's quite different. Okay, for example, denormalization is heavily used in most of the NoSQL database models. Super column family in Cassandra and other such features you can use to avoid costly joins of RDBMS world. So generally in RDBMS world, I join multiple tables to get the required data, but I keep my data in normalized state, because in big data world and most of the NoSQL database anyways don't provide joins and those kind of things. So what I do is basically I keep denormalized data. I make some piece of data repetitive across different column families, so that I don't have to go and look up into another table while returning back the data. Same way in Cassandra, there is a concept called super column family, where you can keep keep necessary or keep those column families together which are related to each other. So it's a kind of set of nested column families. So that is another very useful feature when you are modeling your Cassandra database. You can look at your access pattern and choose the appropriate super column family. So you will get better performance while querying. So in summary, you have to model your NoSQL database very carefully and to try to model it as per the access patterns of your application. So next set of performance tips, these are related to column families, how you can get better performance out of while you are defining your column families. So one parameter is key cached. It is basically number of keys to be cached. So these are just keys. When you enable this setting, you are not actually caching the content of the row, just the keys. So don't just leave this setting on. You have to enable row caching also. Row caching is actual number which determines how many numbers to be cached. Okay, so the higher number of rows you cache, you will need more memory, but you will get better performance while doing the query and read operations. So you have to come up with the appropriate number after various considerations like size of the row, how much updates are happening in the background, all those things, how much memory you can have for your Cassandra, which is a JVM basically. So all these things will come into the play. If you want to populate the row cache at the startup, you can use this setting. So whenever Cassandra is started, it will automatically load your row cache instead of waiting for some hits or something. So it's you are pre-populating the row cache on startup. Mem tables, the bigger the mem tables, definitely you will get better performance during read. Okay, so there are few settings in Cassandra which directly are related to mem tables. For example, how many threads you want for writing into mem tables. So you can tune these settings, but as a general principle, larger the mem tables, you will get better read performance. Of course, heap and all those things will come into the play, but as a generic guideline, you can take it as larger the mem tables, you will get better read performance. Also, each column family is stored on a disk in its own separate file. So keep related columns in the same column family or super column family. It can really improve your performance, because now all the related data which you are querying in your query, which you are going to read in your query, it will be on the same file if you define it in the same column family. So you will get better performance. So there are no multiple seeks happening and all those things. And there is another setting, GC grace seconds. So time to wait before removing tombstones. So all those deleted data which was marked as tombstone, it will be there till the expiry of whatever time you configure. By default it is 10 days, so you can configure accordingly, so that data is unnecessary or unwanted data is removed from the system and it is not hampering your read operations. So next set of settings, next set of performance tips are related to concurrent read and write operations. Concurrent read is one setting which is by default 32. A good value is 4 concurrent reads per processor core. So depending upon how many cores you have, you can use it as a generic guidelines per 4 into number of processor cores. So increase this value for system with fast IO storage, or if you have a bigger machine, you can increase it. Concurrent write, by default this is 32. Cassandra anyways is built for faster writes, and generally this setting you don't need to change more often. With default value it will work perfectly fine in most of the scenarios, but as I said, out of box system, this setting works very fine for most of the requirements, as write is usually very fast in Cassandra. So these are the two tips using which you can increase your read and write speed. So this set of tips is for related to commit log. There is one property, commit log rotation threshold in MB. It determines how large commit log can grow before new file is created. So it is similarly similar to normal log rotation and those kind of things. So after this size is reached, new file will be created. And then there is a property called commit log sync. It can be periodic or batch. If you set it as a batch, it can reduce your performance because it will block until write operation is synced to the disk. By default it's periodic, and in most of the scenarios periodic should work just fine, because batch can have drastic impact on performance. It can degrade your performance, so generally a default setting would work fine, but this is one of the options you can tune. If you use batch, there are certain more parameters you need to define. You need to define batch size and all those things in batch intervals. So but prefer to go with periodic only, unless there is absolute requirement, some kind of requirement where you need to use batch. Most important, I think, as far as Cassandra write operations are concerned, prefer to use separate disk for commit logs to reduce IO contention during write. So if you have separate disk for commit logs and SS tables and those things, there will be no IO contention happening, and you will get very good throughput. That's a generic guideline to have separate disk for different operations. So this set is related to the performance tips for compression. If you use compression, depending upon your data characteristics and workload, etc., it can reduce 2 to 4 times reduction in data size, and 25 to 35% improvement in the read, and 5 to 10% performance improvement on writes. So always prefer to use compressions while you are handling, when you are dealing with Cassandra. So one property which impacts compression is concurrent compactors. Sets the number of concurrent compaction processes allowed to run simultaneously on a node. Higher the number, you will get better throughput, but it can have other side effects like higher disk IO, CPU utilization, etc. So keep in mind while setting this number. But yeah, this property can be used to improve compaction throughput. So next set of tips is related to timeouts of different operations. You need to ensure that you are setting proper timeouts in your configurations for different operations like read and write. Otherwise, if for some reason your application is your read or write operations and other such operations are taking more time than expected, then it can decrease your overall throughput. Application throughput can go down. So it's better to time out after a certain well-tuned timeout period, rather than waiting for longer period of time and then failing out. So some of the timeouts: range request timeout in millisecond, the time that coordinator waits for sequential or index scans to complete. Same way there is timeout for read operations, write operations. So you need to ensure that you are setting up these properties after carefully coming out with proper time intervals or time periods, so that you don't have to wait unnecessary for longer period of times. These are very important properties. So these are the performance tips for your client connecting to Cassandra over RPC. So one important setting is RPC keep alive. So it will enable keep alive connections for your client, so that client can reuse the same connection instead of creating connection every time. RPC max threads. This is the number of maximum requests in the RPC thread pool. It dictates how many concurrent requests are possible. So if you want more concurrent requests from clients, you can increase this number. Of course, it will put more load on your system, so you have to be very careful that your system capacity is it should be able to handle those requests. But that's how you can increase the number of clients or number of requests being made to your Cassandra system. So next set of settings are related. These are kind of mix of different categories. One is related to snitching. If you use dynamic snitching, it will automatically judge which are the nodes which are not up to mark, which are poorly performing nodes, and it will route requests away from this node to better performing nodes. So dynamic snitch monitors read latency and when possible route request away from poorly performing nodes. So always prefer to use dynamic snitching in your application. For Bloom filters, there is a attribute, there is a configuration item called Bloom filter FP chance. It represents desired false positive probability for SS tables. Higher settings you set, it will use less memory but will result in more disk IO in your SS tables. So you have to be very careful. There are some predefined values which you can use for different strategies. Always go with those. And then always keep an eye on compaction also, because compaction sometimes can it can bring drastic performance degradation in your system. So you have to keep an eye on compaction, and if needed you can always go and throttle the compaction by using this property, compaction throughput megabytes per second. So now your compaction rate will not be will not go higher than this value. So that's why how you can throttle your compaction. So these tips are JVM related performance tips. We will not be touching going deep dive into JVM because that's a totally separate topic of performance tuning. But at high level, try to set a heap minimum and maximum size as the same. When you're launching your Cassandra JVM, make sure both heap sizes, the min and max, are set to the same value. Disable the assertions of the JVM being launched. And then there are some properties which you pass on the command prompt which are related to garbage collection, kind of garbage collection algorithm you want to use, survival ratio and max tenuring threshold. So survival ratio and max tenuring thresholds, this basically these control how much objects which are surviving your garbage collections, what should be the space allocated to them in the heap, and all those things. You should be setting up this after doing some kind of load testing and benchmarking. You can use standard JVM tuning tips and troubleshooting tips or debugging tips like JConsole, heap memory analyzer, and all those things to figure out how your heap and your JVM is behaving. If you want thread dump analysis, you can use any standard Java thread analyzer. But main point is you should be setting up these values only after doing proper debugging and analysis of your JVM heap usage pattern. Otherwise, your heap itself can kill your Cassandra performance. So that's the end of this discussion about Apache Cassandra performance tuning. Hope you liked it. And in case you have any questions or any comment, any clarification, just leave in the comment section and I'll get back to you as soon as possible. Thank you guys very much. Thank you very much. Bye.